Okay, we're going to solve inequalities by multiply or divide. Solve inequalities by multiply or divide. The goal is the same as before, and that's to get the variable alone. Get the variable alone. And we're going to do that today by multiplying or dividing. Okay, I need to explain something to you before we get started, so don't write this, just watch and learn. Watch and learn, please, silently. Okay, I'm going to do some dividing and then some multiplying with two numbers and see if we can see a pattern. So let's say I take the numbers 6 and 12 and I divide by, let's say, 3. If I divide 6 by 3, that's 2, and if I divide 12 by 3, that's 4. So looking at this 2 and 4, we know that 2 is less than 4. Okay, so if I divide by 3, we know this over here is going to be less than. All right, let's do the same thing. Like this time, let's divide by 2. If I divide by 2, this is going to be 3, and 12 divided by 2, 2 goes into 12 6 times. So again, the arrow still goes this direction, it's still less than. All right, let's do the same thing with the number, I think I made a mistake. Yeah, okay, let's do the same thing with the number 1. Again, dividing both sides by a 1. If I do that, this will be 6, and on the right side, this will be 12. Okay, again, the left side is less than the right side. Okay, so when divided by 3, 2, or 1, both sides, it still is, the symbol is still the same, it's less than. Now let's divide by a negative 1. Both sides. Okay, so if I do both of these by negative 1, this is going to be negative 6. And over here, this is going to be negative 12. Okay, now, negative 6 is more than negative 12. So it goes like that. Now it's greater than. This is greater than. If I divide by negative 2, this is going to be negative 3. And over here, this is going to be 12 divided by 2 is 6, so it's going to be negative 6, which is greater, or what is negative 3 is more than negative 6. I'll do it one more time here. This time we'll do it with negative 3. 6 divided by 3 is 2, and there's 1 negative, so that's negative 2. And over here, 3 goes into 12, 4, and there's 1 negative. So again, negative 2 is more than negative 4. One observation to make is that whenever I divided by a positive, it was less than, but when I divided by a negative, I had to change the arrow. I had to reverse the arrow. So when I divide by a negative, I need to reverse the arrow to make it true, to make the left side true to the right. Now I'll quickly do it with multiplication. Okay, we know 3 is less than 4. If we multiply by 3, let's see, that's going to be 9 and 12. It's still less than. The left side is less than the right side. Okay, we know 3 is less than 4. If I multiply by 2, will it stay the same? That makes it 6, and this makes it 8. So yeah, that's true. It's still less than. Okay, I know 3 is less than 4. If I multiply by 1, will it still be true? That's 3, and this is 4. Yeah, it's still true. Even if I multiply by 1, positive 1 is still true. Okay, now let's go ahead and see if this is true if I multiply by negative 1. Left side, right side, multiply by negative 1. Is it still true? This will be negative 3, and over here, this will be negative 4. So no, it's not true. Whenever I multiply by a negative, it seems as though I have to switch the arrow. I have to reverse the arrow. It's not true. So I know that 3 is less than 4. If I multiply by a negative number, like negative 2 on both sides, that gives me negative 6, and this gives me negative 8. This is not true. Negative 6 is not less than negative 8. It's more than. So see, I have to switch the arrow whenever I multiply by a negative number. Same thing here. If I multiply by negative 3, that gives me negative 12. And on this side, it gives me negative 9. So this is not correct. Negative 9 is more than. So I have to reverse the arrow. So whenever you divide by a negative number or multiply by a negative number, you have to reverse the arrow. Okay, so let's write this rule down so that we have it for future reference. If you multiply or divide both sides, multiply or divide both sides with a negative number. If you multiply or divide both sides with a negative number, then reverse the arrow. Then reverse arrow. But it has to be a negative number. Only with a negative number do you go ahead and reverse the arrow. Okay, I'm just going to draw a line across there, and now we're going to go ahead and start with our examples. Okay, remember our goal is to get the variable alone. To get the x alone, I need to get rid of 3. That's 3 times. I have to do the opposite of times. I divide by 3. Okay, so that is gone. That leaves it with x. And over here, 18 divided by 3 is 6. Question is, do we reverse the arrow? Let's see, the rule is reverse the arrow if you multiply or divide both sides with a negative number. Am I dividing by a negative number? No. So you leave the arrow alone. On number 2, again, we want to get the variable alone. That's times, so we need to divide. I'm going to divide by -2, both sides. Okay, so this cancels out, and you're left with x. And 16 divided by 2 is 8. Excuse me. I mixed up my colors here. Okay, 8, and there's one negative, so it's -8. Question is now, do we reverse the arrow? Yes, because I'm dividing by a negative number. See that? I'm dividing by negative on both sides. Therefore, I need to change the arrow. Change that arrow. Okay, number 3, I want the variable alone. That's 4 times, so that means I'm going to have to divide by 4, both sides. So that gives me x. On this side, 4 goes into 28, 7. There's one negative, so it's negative. Do I reverse the arrow? Well, let's see. Did I divide both sides by a negative number? Hey, there's a negative number here, but I didn't do that to both sides. It's the number you put down below or up on top, both sides. The answer is no. I don't have to reverse the arrow. It stays the same. It's only if you're doing it to both sides. Okay, to get the variable alone on 4, this is divide by 3, so I need to do the opposite. I will multiply by 3. Okay, that's going to leave me with just x. We got the variable alone. 6 times 3 is 18. And let's see, I multiplied by a positive number. So no, the arrow does not change. Okay, on number 5, notice I'm dividing by -4. To get the variable alone, I would have to multiply by -4. See that? That's how it gets rid of that -4 down below. I have to do this to both sides, though. So this all cancels out, reduces to 1. You're left with the letter x. On the right side, 3 times -4 is -12. Do I need to switch the arrow? Yes, I multiplied by both sides by a negative. So therefore, I need to switch the arrow. So the arrow is going to go this way. Less than. And also notice that the coefficient, -4, so to get rid of it, I have to multiply by -4. So if the coefficient is negative, whether it's on the bottom or top, you're going to have to reverse the arrow. Okay, I've already gone down the page. This is how also you should do your classwork, your homework, assignments. Go down the page and come back up and go down again the other side. Okay, I have -7 times x. So to get rid of the times, you have to do the opposite. You have to divide. To get rid of the -7, divide by -7. Must do that to both sides. So that makes it reduces to 1. 1 times x is x. And 7 goes into 28 4 times. Only this time the negatives cancel. The question is now, do I need to reverse the arrow? Let's see, I'm dividing by a negative on both sides. See that? I'm putting -7, -7. So yes, I'm going to have to reverse the arrow. All right, we have 6 times x. So the opposite of times is divide. That's a +6, so I'll just put down a +6 below it. See, that will reduce to just x. On this side, again, I have to divide by 6. So on this side, left side, it just gives me x. On the right side, that gives me 6 goes into 35, and there's one negative, so it's negative. And let's see, do I need to switch the arrow? Let's see, did I multiply or divide by a negative number on both sides? Both sides, not just one side. Here I divided by 6. Divided by a +6, divided by a +6. The answer is no. The arrow stays the same. See, it's what you put down on both sides. If it's a negative on both sides that you put down, write down, then you reverse the arrow. Okay, here we have half of x. Now watch this. If you want to, by the way, x is on top. So if you want to, you just go like that. Notice the coefficient is 1/2, or you could say it's just divided by 2. So we will multiply by 2, both sides. And if I do that, the 2's cancel, and you are left with just x. It reduces to 1. 1 times x is x. On the right side, 9 times 2 is 18. Okay, let's see, I multiplied by a positive number on both sides. Does the arrow change? No, it stays the same. Little twist here. Now we have x on the right-hand side, the variable. Same procedure. You want to get rid of the 7. Right, that's divide by 7, so you multiply by 7. Both sides, you have to be fair. So this cancels out, reduces to just 1. 1 times x is x. The left side, 7 times 2, that's 14. And does the arrow stay the same? Yeah, I multiplied by a positive. The arrow stays the same. But you know what? I'm going to have to flip this around, because to graph this would be, you'd have to go against the arrow. So to make things a little easier for us, I'm going to put this to the side. If I put x on the left and 14 on the right, I'm going to have to reverse the arrow. Yeah, I keep the arrow pointing to 14. So really, this is the way we want to write it. Then yeah, this is another way that we're going to have to switch the arrow around, reverse it. So if you have x on the variable on the right-hand side, and you want to graph it, switch sides, but you're going to have to switch the arrow too. Okay, this is a very tricky problem. I have x on the right-hand side, but also notice that there's a negative coefficient. So to get rid of -4, you want x by itself. To get rid of -4, I'll divide by -4. You have to do that to both sides. And if I do that, this will end up being x. 16 divided by 4, that's 4. And there's one negative. And I'm going to have to reverse the arrow because I divided by a negative on both sides. So I reverse the arrow. Okay, but now, if I was to graph this, I'd want x on the other side. So to switch that around, if I put x over here on the left, and I put -4 on the right, see the arrows pointing to the x? You point the arrow to the x. This is how we like it to be, so we can graph it a lot easier. So it's like we reverse the arrow twice to get what we wanted.